Hello, welcome to Cloud Channel. In this module, we will talk about how to implement a big data architecture in Microsoft Azure. So we will discuss about what is big data and how to implement that in Azure and what are the data sources, data storage, batch processing and stream processing, and analytical data store and analytics and reporting. We will discuss all these topics in this module. What is big data? Big data can be described in terms of data management challenges that due to increasing volume, velocity, and variety of data that cannot be solved with traditional databases. While there are plenty of definitions for big data, most of them include the concept of what is commonly known as volume, variety, and velocity of big data. Let's talk about on these three concepts: volume, variety, and velocity. Volume is ranges from terabytes to petabytes of data, and variety includes data from a wide range of sources and formats. Example: clickstream, weblogs, social media interactions, e-commerce, devices, sensors, dashboards, and online transactions, financial transactions. What is velocity? Velocity is increasingly business have requirements from the time data is generated to the time actionable insights are delivered to the users. Therefore, data needs to be collected, stored, processed, and analyzed within relatively short windows ranging from daily to real time. Why we may need big data? Despite the hype, many organizations don't realize they have a big data problem, or they simply don't think of it in terms of big data. In general, organizations are likely to benefit from big data technologies when existing databases and applications can no longer scale to support sudden increases in volume, variety, and velocity of data. So in a lot of cases, we see when we are loading data into traditional databases, we see the issue there is no more room in database. So we see all these issues, so we cannot scale up. But so to avoid these problems, so big data is the right solution. Big data architecture is designed to handle the ingestion, processing, and analysis of data that is too large or complex for traditional database systems. Big data solutions typically involve one or more of the following types of workload: batch processing of big data sources at rest, real-time processing of big data in motion, interactive exploration of big data, predictive analytics, and machine learning. So most of the big data architectures include the following components that we see in the diagram: data sources, data storage, real-time message ingestion, batch processing, stream processing, analytical data store, analytics and reporting. So we will discuss about each of these components and how we can implement this in Microsoft Azure. There are a lot of alternate tools that we can use in Azure, Microsoft Azure provides. So we can use those tools to implement this big data architecture in Microsoft Azure. So these are the architecture components that we just discussed: data sources, data storage, batch processing, real-time message ingestion, stream processing, analytical data store, analysis and reporting, orchestration. Let's talk about each component in detail. Let's talk about data sources. All big data solutions start with one or more data sources. Examples that include application data stores, such as relational databases, the Teradata, SQL Server, or Oracle, or any traditional relational databases, and static files produced by applications such as web server log files, and real-time data sources such as IoT devices or sensors, or any, like, example, when you are um, going on highway, you can see that, like, the sensor that you have easy pass, that, like, that is the sensor device. So these are the real-time data sources. What is data storage? Data for batch processing operations is typically stored in a distributed file store that can hold high volumes of large files in various formats. This kind of stores, this kind of store is called data lake. So we know that there are, like, multiple options available in Azure, that we can use Azure Data Lake Gen 2 storage to hold the massive amount of data in Azure. So the options for implementing this data storage include Azure Data Lake Store or blob containers in Azure Storage. Next one, batch processing. Because the data sets are so large, often a big data solution must process data files using long-running batch jobs to filter, aggregate, and otherwise prepare for the analysis. So usually these jobs involve reading source files, processing them, and writing the output to new files. So we have a lot of options available to do these: filter, aggregate, and prepare the data for analysis. The options include running USQL jobs in Azure Data Lake Analytics, and using Hive, Pig, or custom MapReduce jobs in Azure HD Insight cluster, or using Java, Scala, or Python programs in an HD Insight Spark cluster. So there are modules available in my channel, that Azure Data Lake Analytics, how we can access the file from Data Lake Store and then run this USQL job. And also I created one more module for HD Insight. Please go through that module. It shows how to run these jobs, how to process these batch processing jobs. And next one, real-time message ingestion. We just discussed about real-time data source. If the solution includes real-time sources, the architecture must include a way to capture and store real-time messages for stream processing. This might be a simple data store where incoming messages are dropped into a folder for processing. However, many solutions need a message ingestion store to act as a buffer for messages and to support scale-out processing, reliable delivery, and other message queuing semantics. So we have a lot of options available in Azure. We can use Azure Event Hubs, Azure IoT Hubs, and Kafka. So we can use all these three tools to ingest the data from real time. So what is the difference between Azure Event Hubs and Azure IoT Hubs? Because even though they both provide the same, they both for same reason, like real-time ingestion, but Azure Event Hubs are built for a big data solution, and IoT Hubs for the data ingest from the devices. So this is one of the difference that Microsoft Azure recommends Azure Event Hub to process the big data. The next one, stream processing. After capturing real-time messages, the solution must process them by filtering, aggregating, and otherwise preparing the data for analysis. The processed stream data is then returned to an output sink. And we have a tool available. We can use that to implement this in Azure Stream Analytics. Azure Stream Analytics provides a managed stream processing service based on running SQL queries that operate on unbounded streams. So there is one module available in my channel, Azure Stream Analytics. Please go through it. So I showed in that channel how to create IoT hub and how to create storage account. So we can ingest data from Event Hub or IoT hub or blob storage, and we can create a job in Azure Stream Analytics, and we can ingest the data and we can run the standard SQL, and we can process them by filtering, aggregating, and preparing the data for analysis. And there is one more option available in Azure. We can also use open source Apache streaming technologies like Storm and Spark streaming in a HD Insight cluster. The next one, analytical data store. Many big data solutions prepare data for analysis and then serve the processed data in a structured format that can be queried using analytical tools. The analytical data store used to serve these queries can be a Kimball-style relational data warehouse as seen in most traditional business intelligence solutions. Alternatively, the data could be presented through a low latency NoSQL technologies such as HBase or an interactive Hive database that provides a metadata abstraction over data files in distributed data stores. We know that Azure Synapse Analytics is a cloud data warehouse where we can do this analytical, and also we can run the complex queries. We can do these joins and run the complex queries. We see the better performance using Azure Synapse. Azure Synapse Analytics provides a managed service for large-scale cloud-based data warehousing. And also HD Insight supports interactive Hive, HBase, and Spark SQL, which can also be used to serve data for analysis. Thing last to left, analysis and reporting and orchestration. Let's talk about analysis and reporting. The goal of most big data solutions is to provide insights into the data through analysis and reporting. To empower users analyze the data, the architecture may include a data modeling layer such as multi-dimensional OLAP cube or tabular data model in Azure Analysis Services. And it might also support self-service BI using the modeling and visualization technologies in Microsoft Power BI or Microsoft Excel. Analysis and reporting can also take the form of interactive data exploration by data scientists or data analysts. So for this kind of scenarios, so many Azure services support analytical notebooks such as Jupyter, enabling these users to leverage their existing skills with Python or R. The last one, orchestration. Most big data solutions consist of repeated data processing operations encapsulated in workflows that transform source data and move data between multiple sources and sinks, and also load processed data into an analytical data store or push the results straight to a report or dashboard. To automate these workflows, we can use an orchestration technologies such as Azure Data Factory or Apache OZ and Scoop. So we have all these options how to schedule these workflows using Azure Data Factory. So there are a couple of modules available in my channel about Azure Data Factory orchestrations. Please go through them. The next one, Azure includes many services that can be used in a big data architecture. So we just discussed how we can implement all these components with various tools in Azure. Because these fall into two categories. all these services in Azure, managed services, and open source technologies. For managed services, Azure Data Lake Store, where we can store massive amount of data. Azure Data Lake Analytics, where we can access the file and run the USQL jobs for analytic purpose. And Azure Synapse Analytics, that is cloud-based data warehouse. And Azure Stream Analytics is a real-time analytics. And Azure Event Hub and IoT Hub, these are the services for to ingest the real-time data. And the last one, Azure Data Factory for the orchestration. These are all the managed services. What are the open source technologies available in Azure? The open source technologies based on the Apache Hadoop platform, including HDFS, HBase, Hive, Pig, Spark, Storm, OZ, Scoop, and Kafka. These technologies are available in Azure, so we can get all these technologies in Azure HD Insight service. When to use this architecture? Consider this architecture style when we need to use this architecture. Store and process data in volumes too large for a traditional database, and transform unstructured data for analysis and reporting. So we don't have this option available in a traditional database where we get unstructured data and we want to do the analysis and reporting. So we couldn't implement this in traditional database. So we must use big data to do this transform unstructured data for analysis and reporting, and capture, process, and analyze unbounded streams of data in real time or with low latency. Because we see a lot of latency issues, but if we want to capture, process these unbounded streams of data in real time, we should use this big data. The last one is use machine learning and Microsoft Cognitive Services. What are the challenges we face? The challenges are complexity, skill set, technology maturity, and security. Big data solutions can be extremely complex with numerous components to handle data ingestion from multiple data sources. It can be challenging to build, test, and troubleshoot big data processes because we are getting data from unstructured data, structured data, and real time. So to handle this kind of data from multiple data sources, it will be little complex. And next one, skill set. Many big data technologies are highly specialized and use frameworks and languages that are not typical of more general application architectures. So we just discussed about the languages. They use Scala, R, and Python, and also we can use that Hive SQL. On the other hand, big data technologies are evolving new APIs that build on more established languages. Example, USQL language in Azure Data Lake Analytics is based on a combination of Transact SQL and C#. Similarly, SQL-based APIs are available for Hive, HBase, and Spark. Next one, technology maturity. Many of the technologies used in big data are evolving. While core Hadoop technologies such as Hive and Pig are stabilized, emerging technologies such as Spark introduce extensive changes and enhancement with each new release. Last one, security. Big data solutions usually rely on storing all static data in a centralized data lake. Securing access to this data can be challenging, especially when data must be ingested and consumed by multiple applications and platforms. Let's talk about best practices. Leverage parallelism, partition data, apply schema on read semantics, process data in place, balance utilization and time cost, separate cluster resources, orchestrate data ingestion, scrub sensitive data, early. Let's talk about leverage parallelism. Most big data processing technologies distribute the workload across multiple processing units. This requires that static data files are created and stored in a splittable format. Let's talk about partition data. Batch processing usually happens on a recurring schedule. Example, weekly or monthly or bi-weekly. Partition data files and data structures such as tables based on temporal periods that match the processing schedule. Also, partitioning tables that are used in Hive, useSQL, or SQL queries can significantly improve query performance. And let's talk about apply schema on read semantics. Using a data lake, it lets us to combine storage for files in multiple formats, whether structured, unstructured, or semi-structured. So we can use schema on base semantics, which project a schema onto the data when the data is processing, not when data is stored. And next one, process data in place. Traditional BI solutions often use an extract, transform, and load process to move data into a data warehouse. So there are a lot of ETL tools like Informatica, Ab initio, SSIS, or Teradata utilities, which we use and for ETL process to move data into a data warehouse. With larger volumes of data and a greater variety of formats, big data solutions generally use variations of ETL such as transform, extract, and load. With this approach, the data is processed within the distributed data store, transforming it to the required structure before moving the transformed data into an analytical data store. Next one, balance utilization and time cost. For batch processing jobs, it is important to consider two factors: the per unit cost of the compute nodes and the per minute cost of using these nodes to complete the job. And next one, separate cluster resources. When deploying HD inside clusters, we will normally achieve better performance by provisioning separate cluster resources for each type of workload. Example, Spark clusters include Hive. If we need to perform extensive processing with both Hive and Spark, we should consider deploying separate dedicated Spark and Hadoop clusters. And similarly for HBase and Storm. For low latency stream processing and Hive for batch processing, consider separate clusters for Storm, HBase, and Hadoop. So the last two, orchestrate data ingestion and scrub sensitive data early. Let's talk about orchestrate data ingestion. In some cases, existing business applications may write data files for batch processing directly into Azure storage blob containers where they can be consumed by HD Insight or Azure Data Lake Analytics. However, we will often need to orchestrate ingestion data from on-premise or any data source into data lake. So we can orchestrate using Azure Data Factory or OG. The last one, scrub sensitive data early. The data ingestion workflow should scrub sensitive data early in the process to avoid storing it in the data lake. And so far we discussed in this module how to implement a big data architecture in Azure and what is big data and what big data solutions typically involve and what are the most components available, what are the most components used in big data architectures, and also when to use this architecture and the challenges we face when we use big data architecture and best practices. If you have any questions on this implement big data architecture in Azure, please post in the comments. If you like this video, please subscribe and share the channel. Thank you.